In this less demo, we are actually going to try and put together all the scripts that we've learned about to create the input files of the model in one big script so that we can easily just run a single script to do everything. So let's go again in the ROMs NC files. And if I do an ls of asterisk.m, okay, there's a script here that is actually only called main NC file. And this script actually does everything for you. So in this script, the idea is that you configure your grid. So for example, we were working on the North Pacific, so I'm going to put N Pacific. Then you assign here the names of the various climatology boundary file and so forth. Then there's and that's basically all you do. Okay, and then you run the script, and it will generate all you need to do. And in fact, you can see that the script has various sections. It has the first section, do climatology, which calls the two scripts that we've worked before, the climatology TS, climatology UV. Then it has a section where it runs the script's initial condition in OBC. And then it has a section where it runs the climatological forcing. And in this particular case, it adds these two functions here, a function call, which replace the sea surface temperature and sea surface salinity that you extract in the forcing with the ones that you stored in the climatology. And that's just done in order for the forcing and climatological field to be consistent with each other. And then at the end, it just, if you want, it allows you to plot the fields that you just extracted, and that's about it. So in fact, while we look at this, I'm going to save this, and I'm going to go in the MATLAB window here. I'm going to go in the ROMs NC files. Okay, so right now you see we don't have any North Pacific files anymore because I deleted them. So I'm just going to create them all at once by just typing this particular script. It asks me, it tells me, you're doing the N Pacific, which is right. I want to store the files in my output directory, which is correct, and I press return. And then I just basically wait for this to finish. And while this is doing that, let's go back to the edit window. And keep in mind that, of course, this is the main script that runs everything, but then locally you may want to open each of these individual main scripts here and change, for example, some of the options. So for example, suppose main NC file clima, we currently is configured to do the World Ocean Atlas dataset for the climatology. But if you wanted to change that, you can go here and just change this to be, say, equal 1 or 0. Okay, so that's something you could do. Now with this in mind, you also realize what is the usefulness of having this block here. This block basically says that if you already defined the name of the grid, then this script is probably being called by that main script that we're running right now, and so you don't need to redefine all these things. And so this allows you to use this script together in this big general script here. On the contrary, if you just want to run the climatology as a standalone and you're not running this script within the main script, then you can just execute this code and it'll create the things that you need. Okay, so just not going to save this. So the advantage of having such a script as a general script like this is that in principle, if you want to, for example, change a grid, you just go here. For example, suppose that now I want to run the Southern California bike grid. I just do that. I save this, and then I go back in my MATLAB. And once it's done doing the North Pacific files, which I'm going to use later for the next set of tutorial on the North Pacific ROMs application. Once this is done, I'm going to rerun this, for the SCB, for the Southern California Bight. So let me just finish 1 second the North Pacific files. It's doing right now, I believe it's doing the forcing already, so it's the last step. Yeah, now it's saving the forcing fields. In the meantime, I'm having a cookie. Now it asks me if I want to plot things. I don't want to plot things. So it took about 156 seconds. And I'm going to do ls minus rtla. And now you see that you have all the North Pacific netcdf files. Of course, if you now want to change, again, you want to modify just the forcing fields, you can open the main fork file and just change the forcing field or whatever you want to change. Now, let's go back and now let's do a clear. And let's say that we want to produce the SCB grid, the Southern California grid. And I'm just going to show you what this looks like just for before we even begin. So this is just another grid, okay? And you can load any grid you want at this point, right? This is very general. So this is a grid that only the California current, for example. And so the first thing, before I run this script, I can just rerun this main NC file. I have to realize that once I run the climatology stuff, it will produce a WOA.mat. This is the climatology for the North Pacific in this case. And so sometimes, suppose that I was doing an Atlantic thing, this climatology is only for the Pacific, and so typically you may want to remove this when you change and you work with a different grid. So you may want to remove that and also the soda.mat if it exists. Because if you remember, in the climatology thing, to save you time, if you go in the climatology, you find that if World Ocean Atlas.mat exists, it just loads it without recomputing the climatology for the grid. So if you change grid, you have to remove this file in order to produce it for a different grid. Now in this particular case, since this climatology file is still over the North Pacific and California current is over the North Pacific, it wouldn't be a problem. But just for as a proof of concept, I am going to remove WOA.mat. Okay, so now it's no longer there. Okay, so with that in mind, then we just set in the main NC file, we set the new grid to be SCB, and then we just execute this script, and we press OK, and this should produce. Right now, it's extracting the climatology from the World Ocean Atlas, and this is typically something that takes a lot of time. In fact, when you do the North Pacific grid, you'll find that it will take probably like 15 or 20 minutes. In the case of the example that I just did for you, I had saved the .mat file with the climatology, so I just had to load it, didn't have to re-extract it. And this is just to speed up things as I show you the demo. So here you see that now in this case, because the grid is very small, the whole extraction process is actually very quick. So now it's creating the initial condition, boundary files, and now the forcing. See, it's pretty quick. And I'm gonna put 0. Took about 70 seconds. And now here you have all your SCB files ready to use with the ROM simulation. Okay. So to stress out again the importance of checking whether your climatology files are deleted, if for example now I redid this thing and I used a different grid, for example, let's assume I used I think I have an Atlantic grid. Let me just check that. So just as a proof of concept, let's do clear GRD equals, I think I have an intra-American seas grid, yes, 20. Yeah, so I have this grid here. This is a grid of the Caribbean. You see, so it's over here. And so I'm going to run this script again. I'm going to call this IAS20 here. So I'm going to open this, and I'm just going to produce a set of initial climatologies and stuff for the IAS20. Okay. If I do this, and I start that, you'll see that after it creates the climatology, it actually is extrapolating. You see, it tells you there's some NaN values, and that's because I forgot to remove the WOA.mat file, and this has the climatology only covering the regions of California, so there wouldn't be any use. So I have to remove this first, and then I can actually run this so that it extracts a new set for this particular area. And I'm not sure how long this is going to take. I'm actually trying this on the fly, but You see it's taking a little bit longer because this is of course a larger region, but you know it has to do 12 of these, so it's time level 1. It typically the World Atlas has 32 vertical levels, and so 31, 32, and then now it goes on with the remaining part. And if you were to wait long enough, you'll basically uh, have at the end of this set of files, you know, for the IIS grid. It already created the climatology file, you see, and so you can go on and create files for any grid you want, and you can and of course these are not necessarily the type of configuration. Climatological stuff is not necessarily the type of configuration you want to run with, but it is a start to get you know, started with the model. And you can always modify these, and we'll see some examples of how to modify this initial set in some of the examples that will follow in the tutorials. Okay, so I'm going to close this tutorial here. I'm not going to wait for this to finish its interpolation because it'll take some time. It's now at May 5th, so I'm just going to end here. And once again, remind you that you can basically run all this stuff by using this main NC file thing, and just put here, you know, the grid that you want to work with. Okay, so this is all. Thank you.